Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Innovating Equipment Mounting Using HVACR Technologies. My name is Amanda, and I will be your host today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional owners of the land and recognises their continuing connection to land, waters and community. We pay our respects to their cultures and to elders past, present and emerging. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Conform Group. Conform Group is Australia's first fully fledged engineering company for HVACR platforms, acoustic and architectural screening and roof access systems. Specialising in mounting mechanical equipment, their expert team of in-house engineers and designers consult on requirements for project needs. Their engineering services include certifying existing structures and delivering engineering solutions. Conform, design, certify, manufacture, supply and install to project-specific requirements, including retrofits, new builds and upgrades. Today we will hear from two speakers followed by our live audience Q&A session, and I encourage you to send questions through to our speakers via the YouTube chat box during today's presentation. I'd like to welcome our speakers for today, starting with Nigel Crowe. Nigel is a founding member and managing director at Conform Group, a family-owned and operated business. Nigel's passion for engineering, innovation and problem solving has led to the success of the Conform Group today. Nigel will also be joined by Jeff Ball. Jeff is a specialist structural engineer who has been a progressive, hands-on designer for more than 40 years. He commenced his career as a cadet engineer with Longworth and Mackenzie in 1969 and graduated with a diploma in structural engineering from NSWIT in 1974. Whilst working full-time in general consultancy on residential, commercial, educational and institutional buildings, Jeff continued his studies and completed a degree of Bachelor of Structural Engineering with honours from UTS. The early years of his career also included employment with New South Wales Public Transport Commission, designing bridges with Andrew Shirley and Associates, specialist geotechnical consultants. As the director of Vision Water, Jeff directed the research and redevelopment of the patented water cell rainwater harvesting system in conjunction with the Newcastle University. Jeff has continued his role as Director and Principal Engineer of Vision Structures and has been actively involved in the design of more than 6,000 projects over his career. Please welcome Nigel Crowe and Jeff Ball.
Thank you, Amanda, and welcome, and thank you everybody for joining us today. As Amanda said, my name's Nigel Crowe and I'm the Managing Director here at Conform Group.
Good afternoon. I'm an independent consulting structural engineer in private practice, and I'm probably in a similar situation that a large majority of the audience is in.
So the purpose of today is really to discuss around some of the challenges facing the industry, challenge some of the traditional methodologies that have been used for years, and introduce you to some of the solutions that we have developed to answer to these. So I guess just as by way of opening up an introduction, as we know, is the value of land has increased and real estate becomes more scarce. And we've seen the demise of dedicated indoor plant rooms as part of the base build. in favour of placing plant and equipment HVAC on the roof area. Now, in terms of the natural selection of somewhere to permanently locate HVAC, this is obviously logical. Large open areas of space. It does, however, come with its own unique set of challenges. So we'll explore through some of those.
So, as a designer, what role do we play, and how do we generally get introduced to a job of this nature involving the replacement or installation of new mechanical plant and equipment within either new buildings or replacements in existing buildings? Our client is generally a contractor, and our role is to facilitate an outcome. And our client is generally in a competitive tender quotation environment. And so I see it as our role to support our client to try and come up with the most effective solution to assist our client to win a tender. Now, our client is generally not the owner of the building, and so there are other stakeholders who are affected directly by any works that might be undertaken on the building. Our client is generally making a tender for a business owner who may be a tenant in a building, or it may be for the building owner themselves. But the commercial reality of the situation is that we're trying to assist our client to win a tender, and our client is trying to be as cost competitive as he possibly can be. We have other commitments and requirements, and so therefore our aim is to find the most effective solution. Our solution must be structurally compliant, of course, but we also need to consider the safety of the workers on the job, the users of the building. Most of the time when these works are being done, the buildings are generally occupied, and we need to consider the safety on the maintenance contractors. We also need to build in a contingency for the long-term maintenance of the plant and equipment and for the longevity of the building itself, to ensure that we don't do something that may well be cause a detrimental effect to the building over the longer term.
So on this slide here, we can see some, obviously not all, of challenges that affect building owners when the decision is made to put a piece of HVAC on a roof. There are a number of changes. We as a company obviously work through each one of these in detail with the client. A large one that seems to always come up obviously is acoustic screening and the needs thereof. Obviously noise produced by the mechanical equipment is something that does need to be considered and needs to be reduced to a suitable level. So that's a subject for another meeting, but what we're wanting to really focus on today is four of the main structural challenges that are faced. So longevity, weight, cost and history are something that we'll be talking about through the next slides.
Now, Nigel has gone through the challenges that he perceives as a supplier of a structural product. But as the structural engineer, our challenges are a little bit different to achieve a similar end. As a designer and a specifier of providing permanent infrastructure, we also have a responsibility to ensure that we are not derelict in our duties to the owner of the building, whoever that may be. Generally, the owner of the building is not our client, but our design must ensure that the structural integrity of the building is not compromised. We really need to ensure that the material condition of the building is not damaged due to the additional new work that's being done, either in the short term or the long term. Further, we need to ensure that the waterproofing and integrity of the roof and the walls and the building generally is also not compromised in the short or the long term, and that the work that we do doesn't, where possible, add to the long and short term maintenance of the building. And in a lot of ways that is quite difficult. And so we need to try and identify what consequences our work may have an impact on the future operation of the building and the general maintenance that's required.
So as we can see in this slide, the inherent nature of traditional structural steel is one that doesn't have a infinite life. As we can see, Australia does have one of the harshest climates in the world, and this can be seen a lot on roofs. Roofs are large, unprotected areas, and a lot of the time when plant decks or frames need to be reused, it's actually found that they have come to the end of their life, redundant through rust, through not knowing what their connection details are, etc. And these then have to be replaced, obviously, at the building owner's cost, and sometimes this comes as a bit of a shock to them. Usable life of the mechanical equipment mounting system is obviously something that is very important to the building owner. Another one of the points to bring up, obviously, is the weight. Structural steel inherently is extremely heavy, and obviously the longer it's got to span, the deeper the beams have to be.
This slide typically shows what we're confronted with on almost every occasion when we are asked to provide a design to support new mechanical plant, any form of infrastructure. Sometimes we're talking about HVAC platforms, but sometimes solar systems or telecommunication towers or dishes. But almost inevitably, on a building of any significant age, there is some form of structural platform system that exists, and it's generally in various stages of decay. And once again, because our client is in a very cost-competitive situation, they generally want us to try and design around whatever existing structure may be there that they might be able to utilise to save money or reduce their price or help them to win a tender. Unfortunately, we have to draw a very, very strict line in our advice to our client. And if our client wishes to utilise existing platforms or structural elements that may be present, we make it conditional that these structures need to be remediated or restored to a suitable level to ensure that the integrity of the building is not compromised over the longer term. This can impact upon the long-term maintenance of other elements of the building that the owner of the building is then obliged to continue to maintain. So invariably, we do come across, in almost every instance, various stages of decay, and we can either, and depending upon how our client would like to proceed, we tell them that this structure needs to be remediated, or we can design a new structure. This is where the conform system has a great advantage because it's all new product and it's not dependent upon any existing infrastructure that may be there. They can move to a different part of the roof or the building and install separately and independently.
So generally at the start, as the structural engineers in the audience know, the capacity of the building is examined, the existing rafters and columns. Now, when a structural steel platform is placed in a roof, sometimes a lot of this capacity is actually consumed by the platform itself. As a result, it leaves less for the actual units. Sometimes additional columns are required to go down into the building itself. Obviously, building owners don't like this. It takes up valuable real estate underneath.
Nigel has entitled this one to do with weight, primarily because structural steel systems are significantly heavier, approximately 3 times heavier than an aluminium system. But there are other significant impacts as a result of weight onto an existing building, and the importance as the structural engineer as to how we deal with that superimposed weight.
Cost we'll look at, this is one of the major ones, really very, very often overlooked. In almost 100% of the cases, the platform itself and surrounds, whether they be airflow, visual or acoustic, are very under budgets. Sometimes, if you're lucky, there'll be some sort of a loose estimate. A lot of the times it leaves out things like time and cost involved in galvanizing, craneage times, which are huge. Time frames are very difficult to try to actually estimate because a lot of accurate pricing isn't actually available at the time. A lot of the time what is actually required is only fully known once the engineer has actually produced the report.
Another example of an existing platform structure which looks like it's in reasonably good condition and may well be utilised. And as the structural engineer, we can evaluate and assess the capacity of an existing system and adapt it to accommodate the new installation. If that is the most cost-effective result for our client, remembering that our client is generally a contractor who is supplying mechanical plant and equipment rather than any structural building elements.
Another very important one is history. So history of the plant platform itself, what it was originally designed for, what its purpose was, what ratings it was allowed to take, what the building underneath was allowed to take at the time, are generally not known in a lot of cases, specifically with existing buildings. We had an interesting meeting several months ago, actually, with Engineers Australia and the City of Sydney. Autodesk were hosting at the time, and that was the future of infrastructure in New South Wales. And the whole meeting was really about the history of buildings, keeping everything up to date, having an archive, knowing what the original design intent and purpose was for each of those parts. So that is something that's very often not seen with your traditional structural steel, and in some cases an existing platform which may be structurally adequate really can't be used because of the lack of this information. Conform Group, on that point, obviously, we actually use Autodesk within our business. Historical plans for every job are kept within our archive. We have a plaque on the side of each of the platforms that we install, and that refers back to a number, and at any point in time an engineer can give us a call and get a full set of CAD drawings and the full history of that platform and what its design purpose was.
We rarely have the opportunity to retrieve any of the original plans of a building. We may get an architectural drawing of some sort. Very rarely do we get any structural drawings. We always visit the site. We make that an absolutely mandatory component of our engagement. We need to eyeball the structure as best we can, carry out a site inspection. We can work from aerial photos, and sometimes we have an emergency evacuation plan, and that's about as good as we get by way of documentation to assist us.
Touch briefly on Australian standards, AS 1170, which our in-house structural engineers use obviously every day. This is more in Jeff's field, and he'll talk on this as well. The basic principle, as we'll know, of a roof itself is that an allowable force of 0.25 kPa, or roughly speaking 25 kilograms per square metre, is what the Building Code of Australia calls for on a roof. So really what that means is that anybody wanting to put anything, any loads greater than that on a roof, obviously can't do that, and the advice of a structural engineer is needed there.
Now, as structural engineers, which I would expect that a large majority of the audience is, we are bound by our design codes. Nigel's identified AS 1170 and the four parts of AS 1170. We, of course, have to work with any other codes, steel structures code or aluminium or whatever componentry is required or our client requires us to be involved with. But generally we find that we have to provide two certifications for the work in which we're involved. Firstly, we're required to provide a certificate of structural adequacy for the existing building before the new work is undertaken. And without any plans, that can be quite a task. And therefore, it's important that the approach that we take to construct or design or provide the specification for the construction of a new platform is not going to be violate the structural integrity of the existing building. And secondly, on completion, we have to provide a certificate for the completed work, and that the completed work is in compliance and in accordance with our design specification. Now, Nigel talked about the superimposed live load on a commercial or industrial building of being 0.25 kPa spread over large areas. And generally outside the industry, they take a rule of thumb that if they can install plant and equipment that on an area basis does not exceed the superimposed live load of 0.25 kPa across the roof, then it will generally be okay. But as structural engineers, we know that most of these commercial buildings, by way of supermarkets or department stores or whatever they are very, very flat roofs, very low grades. They utilise roof sheeting that is capable of pitch of less than 2 degrees, clip locks and high rib sheeting and span deck, 3 degrees, trim deck. And therefore, from a wind load perspective, the design criteria that governs the design of purlins and roof rafters is generally affected by wind uplift. So the superimposed dead load is not necessarily a good yardstick by which to assess the structural adequacy of the building because the purlins under a positive superimposed load of dead load restrained continuously by the roof sheeting means that we can tolerate some reasonably significant additional loads. What is important, however, and we must also be mindful of, is that when they install new plant and equipment above the roof line, which was previously accommodated or housed inside a dedicated plant room, that once the plant and equipment's mounted on the roof, well, then the wind load superimposed on that plant and equipment must also be considered in the support of the platform and then through to the major structural portal frame or roof rafter system.
So there's some pros and cons of structural steel. Obviously, we at Conform Group don't see too much benefit anymore of traditional mounting methods, but they are very ingrained out there in the history of buildings. Generally, the raw materials for them are fairly easy to come by. Structural steel, I-beams, UBs, PFCs, etc., nuts, bolts and washers. So that's one of the reasons why they are opted for steel is because traditionally and up to this point, as we know, access to those materials has been fairly easy. Of course, as we are very aware, especially in this country, that is changing by the day. The price of steel is going up by the day. There is a general international shortage of steel, and obviously freight prices are crazy as well. So access to those previously very readily available products are actually becoming less and less, which brings us to the next slide. Time to embrace change, and what that's looking at really is the entire building industry in Australia has been relying on imported materials for a long time, and it's time now to look inwards into Australia. What can we produce as a country? What can we produce with regards to raw materials? What can we manufacture ourselves using our own labour in order to get products out onto building sites quicker? So now, what the industry really needs, I believe, and not only in HVAC mounting, but indeed in a lot of other areas as well, is systems that are modular, scalable, a good understanding, etc., as our list is here. And companies that are champions in really knowing and understanding that. System that really ticks all the boxes is what we're really needing here. Now, just go over briefly the difference between the two typical types of HVAC mounting that are seen and that are accepted within the industry. On the right-hand side, we have the perla-mounted system, or surface-mounted, as we call it. That's used a lot in newer buildings where the engineer has the luxury of introducing additional purlins underneath the roof itself, and these then obviously direct the load paths through these purlins to the rafters and then back to the columns. What we want to focus on today is the rafter-mounted system, and as its name states, it's basically connected directly to the rafters of the building using stub columns. It's raised above the roof, so no force is exerted in between the rafters on the purlins. So the rafter-mounted system is really the system that we're going to be talking about as an alternative to structural steel.
This is an important slide, not from a point of view of the platform, but from the viewpoint of considering the long-term maintenance of the building. You know, if you look at the photo on the right, which shows the purlin-mounted system, which is a very intricate and involved support system, compared to the one on the left, which is the rafter-mounted system. One of the biggest considerations for a building owner is long-term maintenance of a structure. And when we install platforms or infrastructure of any kind onto a roof, it imposes severe restrictions on the owner of a building to replace the roof sheeting or attend to any other forms of maintenance that might be required. So as a designer, I think we have an obligation there to try and advise our client, recalling, of course, that our client is really a contractor whose principal interest is to install mechanical plant and equipment. But I think from an ethical point of view, we need to at least point out to the contractor of what the design may cause to the building over the longer term, such that he may then address these matters with his client, which may be the building owner. And that way, the building owner may see some benefit in investing in a better system, irrespective of it being possibly more expensive, but a better quality system.
It's to introduce a solution that we have come up with over many years. This is called the Span Plus solution. Essentially, as its name says there, too, spanning across. It sits on stub columns. It's a scalable system. It's modular and it's lightweight. So those are really the three key points that really speak to success within the industry. Timing, etc., is also a fraction of the time of traditional methods. All materials that you see in this image here are actually sourced locally here within Australia. Extruders in Sydney, Melbourne, Brisbane are used for the aluminium joists and bearers. Most materials are kept in stock in our factory as well. a lot of the parts that you see here are actually manufactured as a stock piece that can simply be taken off the shelf, fitted together, packed and sent to site very quickly. In terms of timing, as we know, structural steel platforms, which are 100% custom from start to finish, can take anywhere from 6 to 8 to 10 weeks from the initial design phase right through the installation. To give you an idea, we've actually got a fairly large span plus system leaving this afternoon to go to Perth. The information was given to us last Friday, and it will be installed next Tuesday. So about a week and a half from the start and right through to the finish. And as we've gone through and developed these systems to give some speed and a bit of respite to the industry that is used to waiting, weeks if not months for a system, we've gone through everything right from start to finish, and in terms of the shop drawings and timing, etc. So go through to the next slide. So as the slide says there, it's all in the stub column. Traditionally, holes are drilled and then a stub column is actually bolted onto the top flange. The system that we have come up with is essentially a clamping system. So the system itself clamps onto any size beam. A small hole is made in the roof sheet itself, and then the parts are actually inserted by hand, bolted up together, and the rubber boot is put on the top, as you can see. So again, traditionally, large amounts of the roof has to be removed, and sections of steel have to be welded to the existing, and then everything is sealed up after that, obviously taking a lot of time and money. The system itself is engineered and made here in our factory. As said again, it can fit onto any column, at least any rafter. It doesn't have any detrimental impact on the integrity of the beam. So that's probably one of the main reasons for actually developing this, as well as sometimes it's just not possible to get to the underneath of the roof.
The biggest concern of the structural engineer is to how we attach it to the existing building without causing damage to the building. We certainly insist that the existing principal structural members of the rafters of the portal frames, and particularly the flanges of the rafters of the universal beams or column sections, are not holed or drilled. And of course, the welding of any form of attachments will break any form of galvanising or corrosion protection coatings that might be in place.
Drilling into the structural member is really one of the most dangerous things, I guess, you can do to an existing building. As we know that when a standard stub column is installed, magnet drill has to be employed with holes being drilled in the top flange of the rafter. Now, unfortunately, it's not always possible to get to that area, or the person doing it may find that something's in the way, and sometimes a lot of holes are drilled in the wrong areas and so on, and the rafter ends up looking a little bit like a Swiss cheese, which is a engineer's worst nightmare there. So this system really takes that risk away. No hot works, of course, everything's done by standard hand tools. There's no requirement for welding, oxy, grinding, any of those things that are synonymous with your standard systems. Site assembly is incredibly easy as compared to traditional systems. Again, the system comes to site as a flat pack with all holes drilled ready for bolts, etc. So there's very minimal work involved on site itself. It's also very difficult to get it wrong because everything is pre-drilled, pre-measured. The safety has obviously increased. The system of the size that we see in this image here, if that was in structural steel, those joists and bearers that we see there would each have to be individually craned into place. Generally, you would need to evacuate the building fully underneath. If one of those sections came off the crane, it would pierce straight through the building. With this aluminium system, though, each of the pieces is actually designed to be horizontally moved by hand and putting together, so the building can actually remain habitable throughout the whole job as such.
The prefabricated system has some great advantages here, which Nigel has listed on his slides, that there is no need to hole the main structural members, utilising his clamping system. It eliminates on-site welding, erection and site assembly is simple, easy, and possible for one or two workers by themselves without the assistance of additional mechanical equipment or cranes hanging over the building for extended periods of time. That, of course, increases the safety to everybody involved, all the workers involved, but also the occupiers of the building who are oblivious that this work may be going on. Another important factor that Nigel has identified as his last point there is he's got some minimum swarf there. This is an issue that we find is very, very common and very, very prevalent almost on every roof that we inspect that has some significant age to it, where different contractors have installed different plant and equipment or further infrastructure or done modifications to the building where they are on a building and they're grinding structural steel or roof sheeting, and the swarf is spread all over the roof. And in a very short period of time, the swarf rusts or corrodes and eats away the collar bond coating, and it's not very long before the roof sheeting itself of the building requires replacement. This is an enormous expense, and in a lot of instances is an almost impossible task if the building is covered with air conditioning platforms or telecommunication towers. A lot of contractors hose the swarf off, and therefore the swarf ends up in the rainwater goods, the box gutters and the downpipes, and similarly leads to the demise of those rainwater goods, and particularly if the building's of an age where folded Galvabond has been used in box gutters or something of that nature, well, then they deteriorate so much more quickly, and so the damage caused to the building is very significant and can reduce the life of the roof sheeting.
There's a few images here that just highlight the joists and bearers. So again, it's a very simple joist and bearer system. The stub columns themselves have a maximum distance of 2400 at least. This can be increased. Obviously, the size of the bearer increases as well in that case. So again, stock is kept on hand. Turnaround time is very, very quick. and the system can actually be increased or decreased after it has been put in as well. So if the system needs to be increased because there's additional units, it can simply be bolted on and kept on going. By the same token, if the building owner beneath, if their needs change and they need to have more metre square platform, it's very simple to simply join on there.
So this slide here indicates the specialised clamping system of the stubby column component that has been developed by Nigel and his colleagues.
This just illustrates there's a lot of information on our website, also on the specification sheets to assist the structural engineers just to make their life easier. And of course, for site-specific information, you can call any time and speak to our structural engineers here at our office, and we also obviously do site visits throughout Australia as well if needed. This map of Australia that we're all very familiar with, showing the wind zones, just to reiterate again that all of this is taken into account in extreme detail. While the system is modular, while the system is a proprietary system, it is by no means one size fits all. Live loads, dead loads, wind loads, seismic loads according to 1170.4, all of these things are taken into on a site-specific level as well. Our system produces shop drawings, detailed shop drawings as well, which are obviously critical for lodging in council if needed be. And again, the system can change in shape and size right at the last minute.
It's good that they recognise that this type of infrastructure is required all across Australia, and therefore it's going to embrace areas of very variable wind load conditions. And I understand that their system takes all these things into account, and such that every particular site is assessed and evaluated on its location, as well as its terrain category and the other components of the wind code, which become important. And as a structural engineer or an independent structural engineer, that makes our job so much easier, and that the main thing that we then are responsible for is ensuring that the existing structure, the original portal frames or rafters, are capable of supporting the superimposed platform. And that is our task, to assist with the locating of the platform to cause the least structural impact on the existing building.
This is just an example of what we spoke about before with the Autodesk product that we do use. We have extensive configurators that we've developed over time to make the structural engineers' lives easier. Again, this system will automatically produce a shop drawing. So instead of a shop drawing for a platform like we see here taking 6 to 10 hours to draw, we can see that in the space of this video it will have changed four times. Once the platform is made, the size, shape and the pitch, it is then produced automatically into a shop drawing and emailed straight through to the structural engineer or through to the client. So just to recap, just to go over what we've been talking about, traditional methods versus new methods. We have the two systems here, a clamping on span plus system made from locally acquired materials using local labour to traditional methods with a lot of the raw materials coming from offshore. Again, all of our systems here at Conform Group are backed with a 25-year warranty across the board. So essentially, they will outlast the roof that they are sitting on. Flexibility, again, to point up, the system can be adjusted right up until the last minute. Structural steel alternatives have to really go into the base structure, and once they're in, they can't change. No hot works, minimal swarf over against hot works, and swarf that can potentially damage the roof. Install time is obviously a fraction of the time. Weight at 85% lighter than the steel alternative there as well.
So to recap, from a structural engineer's point of view, it is really a comparison over a purpose-built, purpose-designed structure versus a pre-engineered, prefabricated structure. The big benefits are the time savings, and time is money, and will more than likely provide the facility for our client to reduce their costs and provide a more cost competitive tender for the installation of their HVAC system or their other mechanical plant equipment. You know, the obvious savings, of course, are the time related to the design, preparation of the shop details, the fabrication in a traditional structural steel workshop, the time taken to go to the galvanisers and returned, and then, of course, the erection time and the time in which long-reach cranes may well be hovering over the building for the installation. I see some very great benefits in this system for the structural engineer to assist us in doing our job and to enable the installation of new HVAC systems to be installed on existing buildings, which otherwise might be quite an arduous task and possibly cost prohibitive.
So thank you very much, everybody, for your attendance today. And what we've been trying to address here is really challenge the status quo, explore some new alternatives, initiatives that are happening right here in Australia with local Australian businesses. And we hope we've added some value to your vast experiences, and hope we've given you something to think about. Again, contact us any time with the information below. And thank you very much for your time, and we look forward to answering any questions that you may have. Thank you.
So thank you very much for attending, and I welcome any questions that you may wish to pose regarding the structural aspects of the installation of either the conventional system or what benefits or advantages we've encountered utilising the modular system. Thanks very much indeed.
Thank you. And a very warm welcome to you all, and thank you to our speakers this afternoon for two great presentations, Nigel Crowe and Jeff Ball. What I thought was great is that it was a different format to what we normally use, and I think it worked really well. And I think one of the reasons is that our speakers were asking questions along the way. It's now your turn to get involved. First of all, I want to thank everybody that sent through some questions on registration, and we might start with those. We've got about 30 minutes of Q&A time, so encouraging you all to ask questions. Just pop them in the chat box on YouTube and just who you'd like to direct your question to, either to one speaker or both, which is absolutely fine. So without further ado, getting started, the first question I have that directed to you, Nigel, the question is, how do I know whether to decide on a purlin mount or a rafter mount system? Thanks, Nigel.
Thank you very much, Amanda. So that question is really simply answered in the simple terms by what we covered there earlier with 1170.4 and that allowable 0.25 kPa, which is not really a lot. It can be enough if you're mounting things like smaller split systems and so on, where the actual footprint of the area divided by the weight that you're putting on it, and then generally with purlin or surface mounted platforms being around about 14 kilograms per metre square, it's quite a simple thing just to work that out. If that does exceed that, then generally it needs to be assumed that the structure can't take that, and in that case, that is when a structural company would be involved there.
Thanks, Nigel. And just staying with you, we've had a question that's come in from the ACT, from Lasarth. Good afternoon to you. Saying to you, Nigel, I'm a HVAC engineer, not a structural engineer. We would know the dimensions, weights, and load distribution from our plant. Who would typically design the conform structure and then establish that the roof can support it? I would rather not leave it to the contractor, because by then, if it is established that the existing roof cannot support the load without structural alterations, it could become an expensive variation. Great question, Lisa. Nigel.
Thank you. Yes, and this is one that it comes up very often, and most of the time what we find is that a structural look into the building and what it can take, what its capacity is. It's often looked at quite late in the picture, so it does, and this is something that we do find fairly often, is that it does start to cost a lot more than what was initially thought, when we actually realise the full extent of what the platform costs, weighs at least, what the units weigh, what their combined services coming to and from, ductwork, etc. Once all that's put together, generally a structural engineer is involved at that point, where it's a much better idea to involve a structural engineer a lot earlier on. In terms of answering the question, though, it's really the structural engineer that designs, in a sense, whether the conform platform is used, designs that and then makes that work in with the building structure. So we provide the bag of tools, you might say, for the structural engineers, and equipped with this, they then approach the building as we said before. It does need to have a site-specific visit. We need to check out each of those particular rafters, bearers, columns, etc. But what it does do is, instead of the structural engineer designing something up from scratch, taking a fair amount of time to do that, they now equipped with a modular system that can work on practically any roof. So to answer the question, the structural engineer actually does that part.
Thank you, Nigel. As we hopefully come out of the impact of this pandemic, in your presentation, you mentioned site visits, and you also mentioned that you manufacture the equipment's made locally in the factory. As we come out of the pandemic, maybe starting with you, Jeff, what do you think the changes we're going to see in the next few weeks?
Well, I think we'll get a presence developing that for site inspections can be done, whereas up until now they haven't been able to be done, only in emergency type situations. But site inspections of this nature are really quite involved because, as I said during the presentation, we're not generally equipped with any plans of any type, and so therefore we definitely do need to visit the site. Access onto the roof is generally quite easy. It's been designed. However, we need to access under the roof, and this is generally quite difficult for OH&S reasons. And in large supermarkets and shopping centres, there are generally just suspended ceilings in these areas, and so we've got to try and access ceiling spaces and try and identify the structural framing system, whether it's a portal frame system or a truss portal frame system. What size are our purlins? Where are our haunches? What are the spans of the main frames and the size of the purlins? And in a lot of these instances, the job site is quite remote, regional New South Wales, Victoria. So we have to be very, very mindful that a site inspection, which may be a 2-day event, that we utilise that time very effectively and very efficiently, because whatever information we gather, we've got to assess the capacity of the existing building, whether it be the frames, whether it only be the purlins, depending upon which system you select, as to whether or not it can support the load. I think a very important consideration here is that the serviceability of the building, not only the strength of the building to support these loads, but it's the serviceability of the building as well. Because most of these commercial style buildings have very, very low pitch roofs, almost flat, 1.5, 2.5 degrees, and therefore we cannot tolerate any increase in deflections of any great significance. Any sort of additional deflections may cause negative fall on the roof, ponding of water on the roof sheet, flooding of the side lap joints of the roof sheet. So all of those things need to be carefully considered particularly when we look at the purlin mounted system. And of course, the purlin mounted system also introduces obstructions to replacement of the roof sheeting or any other permanent parts of the building. That's an important thing. Whereas the rafter mounted system gives a little bit of flexibility to access the permanent parts of the roof, possibly do maintenance or replace roof sheeting or something of that nature. But also, another important factor, even if you're using a rafter mounted system on the portal frame, we try and locate the platform stubby leg columns as close as we can to the main frame columns and try and span the ridge or some of the supporting members and stay away from the mid-span of the rafters, because that in turn could impose additional deflection on the main frames. If the main frames deflect, well then the purlins deflect, and you may well end up with a serviceability issue with the roof sheeting.
Thank you, Jeff. And just back to you, Nigel, with the equipment being made in the factory, what do you see that as a benefit to your customers, and particularly in these current times?
Yes, definitely. As we can see, the um, building sites and buildings that are currently getting done, stretching out further and further because of a lot of leaning on products that have come from offshore. As we said before, these products are becoming more and more difficult to actually get, and it really shows in what we're seeing at the moment. As we said before, our products are all sourced locally, and we sort of saw that really probably 18 months to 2 years ago, that it was going to become more and more difficult to get products out of the country. So we've turned in, and we now have relationships with a lot of local companies, and that is really a filter that we work through now. If it's something that we can produce, it needs to be in our promise to our clients that if we say that we can produce something, that we are able to actually get all of those raw materials in a timely manner. We can make everything ourselves, so that if a client does need something on a site on a particular day, in order to be able to load the units on a week from then, we can with all knowledge and obviously with all confidence be able to give that to them.
Thanks, Nigel, and thank you for that answer, because obviously pressure on the supply chain has never been greater in these recent times. Jeff touched on supermarkets in your last answer, and we've had a great question that's come in saying, we do a lot of retrofit work on supermarkets. Have you ever had any pushbacks from supermarkets from any reason and opting to stay with structural steel platform? And I might just start with Nigel with that one, and then we can go over to Jeff. Thank you.
Yeah, thanks for that. The main thing, I guess, with supermarkets, which is probably unlike other types of buildings, is that they really can't afford any downtime. They can't evacuate the supermarket while works are done on the roof, while the roof is exposed, and whilst large structural steel is craned over the top. So this system has really been embraced very well, and is sort of rapidly become the preferred method, really. We've worked in with Jeff on a number of jobs as well, and for all intents and purposes, the shoppers below don't even know that anything's happening above them. Units can be installed, plumbed up, etc., very, very quickly.
Thanks, Nigel. Jeff, do you want to just add some input on that?
Yeah, well, most of the supermarkets are not the owners of the building either. They're generally tenants. And once again, as I say, we're working for a contractor who has a contract generally with the supermarket chain for the renewal or the upgrade of the HVAC system. And so they're putting their new HVAC system onto somebody else's building. So they really want the cheapest possible solution. They do try and encourage to utilise any form of infrastructure that might exist, but most of the time it is more cost effective purely from the time it takes for the complete turnaround from the design stage to the install stage, that if a prefabricated system can be used, well, then it generally works out beneficial for most of the parties involved, from the contractor through to the supermarket chain or the tenant of the building, and the main beneficiary is the owner of the building, who has a much better solution over the long time for the preservation of his building.
Thanks, Jeff. Nigel, a quick question. Do you work off a general square metre rates?
So, with regards to Perla mounted solutions on roofs, it's probably a lot easier to do that because they are a lot more simple in terms of how they actually connect to the roof and where they go, who can do them, etc. With regards to rafter mounted platforms, it's a little bit different because the set of circumstances are somewhat different every time, as Jeff said. So not really on that, although what we can say is that it's very much less in terms of the total amount than if you were to go with a traditional structural steel deck. What Jeff said before obviously was very, very important, that time equals money. And when you're talking about getting a solution up on your roof ready to go within 2 weeks over against 8 to 10 weeks, I think that's really what counts as well.
Thanks, Nigel. And just staying with you, we've had a question. Good afternoon to Cafox, who's asking, Nigel, has this system been designed for seismic loads under AS 1170.4?
Yeah, thanks for that. Yes, absolutely. That's one of the critical standards that obviously we do have to adhere to. Mechanical equipment, as well as all of the associated services, ductwork, etc., whether on top of the roof or within the roof cavity itself, they all have to be attached in a way that satisfies 1170.4. And to no lesser extent does the actual platform itself. The mechanical equipment, obviously, on top of that needs to be then seismically connected to the platform to the structure itself. So that is something that our in-house engineers look at on a job-to-job basis as well. On that note, we see what happened a very short while ago in Melbourne. Something we don't see very often here in this country, but it was just a bit of a wake-up call that seismic events do happen, and it is our duty to obviously comply with that standard. Thanks,
Nigel. And Jeff, over to you. We've had a question come in asking, from HVAC design engineers' perspective, at the time of design, without the input from a structural engineer, other than checking the load is less than 0.25 kPa, what information can we gather? Jeff, are you able to comment on that?
Well, no, without having plans of the original building, there's very little you can do from a desktop analysis. You actually have to go to site, as I said previously, and eyeball the structure and try and determine what we're working with. And clearly, we do not have the cost structure or the fee structure within these sorts of jobs to do a complete design check of the existing frames or trusses or rafters or portal frames. Purlin checks are fairly easy to do, but the others are not so simple to do. And therefore, we intuitively use our experience to try and locate the platform in the area of the strongest part of the frames. And where we know from experience that a superimposed load is unlikely to have an adverse effect on the structure. And that's about as good as we can do. And generally, the buildings are fairly strong, and we're talking about new plant and equipment that may range somewhere between maybe 1 and 3 tonnes or 3.5 tonnes or whatever, and it's distributed over a fairly large platform. So the actual superimposed loads on the column structure directly onto the major framing members of the building is generally really not all that significant. And providing we locate them strategically and carefully from a structural point of view, we don't generally impose significant effects on the building. As I said previously, serviceability is something that we need to consider most, and that's why the best way to do that is to keep your supports and your superimposed point load effects closest to as you possibly can to the column framing structure of the existing building.
Thanks, Jeff. Over to you, Nigel. We've had a question about who installs this system. If it's installed by the HVAC contractor, then who certifies the system? Does some sort of training is required to be provided to the contractor for installation? And that's a great question. Thank you to Sanjeev.
Yes, thank you for that. When looking at the two different systems, the raft mount system over against the purlin mounted or surface mounted systems, the purlin mounted systems are very much easier to put together. We're often asked if we can provide those in a kit form. We provide those with all of the seismic fixings, etc. When it comes to the rafter-mounted systems, there's generally a little bit more to this. It's a little bit more involved penetrating through the roof to connect the stub columns, etc. So that is something that we do ourselves as a company. That's a service that we offer. So we will design, install, certify, commission, ready for the units to be loaded on. We obviously have trained teams in every state. Right now, as we speak, we've got a Span Plus in every state except for Northern Territory, going up on a roof as we speak. So we have a large and also growing team of group of trained teams, and those teams will come on and they will actually that whole job from start to finish, everything ready for those units to simply be loaded on.
Thanks, Nigel. And Jeff, just staying with that theme, particularly for our young engineers who are looking to learn more in this field and from a training and knowledge point of view, what sort of advice would you give to young engineers that are coming into this area, to this field of practice?
Well, it's an experience thing, really. You've got to do it and see it, and most importantly, be guided by some of the older, more experienced people. It's not a textbook solution. It's an intuitive solution. And if you come up with an answer that you are not comfortable with, that you have some doubts as to what is being proposed with the infrastructure, well, then you've got to be upfront to your client and say, look, I've got some issues with this. I'm not certain that the building can take these loads. You've either got to try and design an alternative system or alternatively seek the opportunity to do more investigation of the existing building, which of course from a fee structure could be quite substantial. But you do have to satisfy yourself that the existing building is capable of taking the additional loads. The superimposed loads from the platform itself, that's the easy part. If it's a prefabricated thing, Nigel's team obviously certify their own structural elements and the installation of their elements. But then there's the attachment to the building and also the superimposed loads on the building itself, which have to be considered. So from an experience point of view, I say you get out there and you have a good look at it, and you've got to get into some fairly inaccessible places throughout the existing building. And the other thing that's most important, as I said, you're generally working for the contractor. He's organising a site inspection for you. So one thing you always do before you go, because some of these locations are quite remote, is to ensure that the contractor is providing safe access, not only onto the roof, but into the roof. You don't want to travel a long way and then find they expect you to climb up, a 15, 20 metre ladder that hasn't been properly supported and tied in according to work cover rules and things of this nature. So, or send one of your staff members, an engineer from your staff, off into what could potentially be a dangerous work environment. So it's an experience thing, but careful thinking. It's not overly difficult. It's just good logical engineering judgment, and then follow up with your science.
Thanks, Jeff. And just staying with you, Shadowcat sent through a question, basically looking at if you could clarify what is the scope of the structure that needs to be certified. Is it the scope of work, or did you say it was the whole of the existing building? Just to clear that up, Jeff.
Yeah, okay. Like we said, most of the time we're not working for the building owner. But if you're working, and a lot of the time these are supermarket chains, Coles, Woolies, Aldi, IGA, or whoever, who are tenants in a large building, whether it be, one of the large department style chains. You will find that it will be mandatory from their point of view before they let you do anything to their building, even just put a sign on it. They want a certificate of structural adequacy that, firstly, the sign is okay, and secondly, that the attachment to the building is also okay, and that wherever it is attaching to the building, that the building can take those loads. Now, here in New South Wales, it is also a mandatory requirement if it's new work or any work that is subject to a new DA and CC, you will find that a standard condition of consent will be that a practicing structural engineer must provide a statement of structural adequacy that the building is capable of carrying the superimposed loads, no matter what they may be. Then they'll also ask for a certificate of design to say that whatever design is being, new work's being done, complies with all the current Australian standards, BCA, and regulatory requirements. And then there'll be a third certificate that will be required that on completion of the work, that the work is being done in accordance with the design statement that you've already done, and that the work is being done properly. And then they've kind of got you wrapped up from start to finish.
Thanks for that, Jeff. And we're sort of getting near the close of this session, but Nigel, you talked about technology in the terms of shop drawings, and obviously as the world becomes increasingly digitalised, what do you see as sort of future trends going forward?
I think it's going to be demanded of more and more as we go forward. We've found quite a big swing in the last sort of 5 years of builder companies, especially not accepting anything other than a full CAD design, Revit files that need to be given to them to be put into their main working drawings to see how that will affect the building in terms of weight and wind loadings. So we've had to upgrade hugely in order to get to a level that the market actually demands. And I think that is only going to increase as we go along. Generally, right, now as we speak, everything needs to start with a image or a specification sheet, which then very quickly goes to a detailed shop drawing. So that can take a lot of time, obviously, to actually detail every shop drawing. Important that you have that, and that's why we're putting a lot of time, effort, and money into automating that whole side of things. So if somebody needs a shop drawing, we can generally get that out to them. Instead of a week, it's now coming down to a matter of hours.
Thanks for that. And Jeff, from your perspective, where do you think things are heading?
I think it's not only in the topic that we've discussed today. I think engineering or structural engineering, building of any sort, there are considerable advantages to be gained for any type of a system that can be pre-manufactured and pre-assembled. The accuracy of doing these things is very, very good. It eliminates a lot of site problems. It also eliminates the issue of trade skills on site, which are very much in demand these days, so that if we can accurately design and pre-manufacture components within a controlled environment, like a factory workspace of some description, I think there's some big benefits there. And then we have to transfer that to the site assembly or erection process, and that's where different skills are required. But if we can actually transfer the labour component of it to a very simplified effect, well, I think there's some big benefits and cost savings there, and the possibility that workers can be employed who don't necessarily require skills of a tradesman.
That's a really good point, Jeff. And as we know, we're in probably one of the worst engineering skills shortages for a very long time right now at the moment. Sadly, that's all we do have time for this afternoon. Please join me once again in thanking Jeff Ball and Nigel Crowe for their time and insights shared at today's session. I'd also like to take the time to thank Engineers Australia's industry partner Conform Group, who've actually made this afternoon's webinar possible. As always, we're looking for your feedback. Please help us improve and plan. So if you could take a couple of minutes to complete the short feedback form, which is linked in the description box below. Thank you again for joining us, and we look forward to seeing you at our next Thought Leaders webinar. Thank you and good afternoon.